Hey, what's up guys? Rob here from BreVITy, and today we are going to be solving the three sum closest problem. Welcome back to 2-Pointer Week. I hope by now you have an understanding of what two-pointer algorithms are and why they are so effective. Now before we start the three sum closest problem, let us first solve a subtype of the same problem called the two-sum problem. Once we do this, it's just a matter of making one small change to convert it to a three-sum problem. Now here we are in LeetCode. Now the first step to solving any problem is to carefully read the problem and understand it. Given an array of integers that is already sorted in ascending order, find two numbers such that they add up to a specific target number. So it's pretty simple. Let me show this to you in a whiteboard. They'll give an array such as this 2, 7, 11 and 15, which is in the ascending order, and they'll always give a target number, which is in this case 18, and we're going to try to find two numbers that when added is going to give us 18. Now looking at the problem, we can clearly see that 7 and 11 are the numbers to be added. So it's all a matter of implementing an algorithm. So over here we are going to use the two-pointer technique. So we are in the previous video we used another iteration of the two-pointer technique called the fast and slow pointer. Over here we are using another iteration, which is the left and right pointers. So I'm going to create one pointer over here and one pointing at 15. So right now we'll call this pointer as left and we'll call this pointer as right. Now what happens when we add the two numbers which are enclosed in left and right? 2 plus 15 is 17 and 17 is lesser than 18. So whenever we encounter a number that is less than the target, all we are going to do is increment the left variable. So now we need to add 7 and 15. Now what happens when we add 7 and 15? 7 plus 15 is 22, which is greater than 18. So whenever we encounter a value that is greater than the target, what we're going to do is we're going to decrement the right pointer. So when that happens, we can see that right now left is pointing to 7 and right is pointing to 11. Now when we add the 2, we get 18, which is our target. So all we have to do is return the indices of the left and right pointer and we have our solution. Now what will be the terminating condition? That is when we do not find such a target in the array. So in that case, let's assume the target to be 19. Now according to the algorithm, we are 7 plus 11, which is 18, and 18 will be less than 19. So we're going to attempt to increment our left pointer. When we try to increment our left pointer, left will now end up pointing exactly where right is, over here. So when we have both of them on the same place, we can conclude that such a solution is not possible in this array and we can directly return false. So the terminating condition will be while left will be lesser than right. Now that we have understood the algorithm, let's now implement the logic in LeetCode. Now the first thing we can notice is that the return type of the function is an integer array, where the first element in the array is going to be the left pointer and the second element is going to be the right pointer. So I'm going to declare an integer array called result and it's going to be of type integer with a length of 2. Next, I'm going to declare my left pointer, which will be pointing at 0 initially, and the right pointer will be pointing at the last index of the array, which in this case will be numbers.length minus 1. Now, while left is lesser than right, let's say in sum is equal to numbers of left plus numbers of right. So now if sum equals target, we have found our answer. So we are going to return it. So result of 0 is going to store the left index value and result of 1 is going to store the right index value. Now I'd like you to notice one point over here. They want us to give our returned answers and it should not be 0 based. What that means is the first element will be classified as 1, the second element 2, third element 3 and so on. So what we have to do over here is we have to return left plus 1 and right plus 1. And then we just directly return our result. Okay, so that is if we find the target. Now what if we are lesser than or greater than the target? Well, if our sum is going to be lesser than the target, then we are going to have to increment our left pointer. So left plus equal to 1. At the same time, if our sum is greater than target, we are going to have to decrement our right pointer. So it's going to be right minus equal to 1. And outside the while loop, we'll be returning result again. So let's try running it. Okay. So we can see that we have gotten the solution, and if we were to discuss the time complexity of the solution, it's going to be O of n, where n is the length of the array. And this is because the array was already sorted. If the array wasn't sorted, then we'll have to sort the array first. So we'll be doing arrays.sort, and Java implements quicksort internally when it comes to integers. So then it will become a time complexity of O of n log n. And of course, our space complexity for this solution is going to be O of 1. And that is because we are not declaring any new data structure. So we are not allocating space to anything else other than these. And this is only going to be constant. Okay, so now that we have understood 2-sum, let us move on to the 3-sum problem. Now the 3-sum is very similar to the 2-sum problem, except that instead of adding 2 numbers to get an achieved target, we are attempting to add 3 numbers to achieve the same target. That's all there is to know. So to do this, we'll be just using the same code, the same logic, except that we'll be adding one loop. So it's basically going to be the same code as the 2-sum problem with one added condition. Now what is that condition? We are going to add one more pointer. Now over here, this is a possible array which can be given -1, 2, 1 and -4, and the target is 2. Now we can see that the array is not sorted. So the first step is to sort the array. Once we sort the array, we are getting -4, -1, 1 and 2. So I'm going to first declare a pointer k, and I'm going to make it point at -4, which is the first element of the array, right? So the leftmost pointer now we are going to call k, and then whatever is remaining on the right hand side of k, we're going to subdivide that and we are going to make it as the same as a 2-sum problem. So inside that subdivision, we are going to have our left pointer and right pointer behaving exactly the same way as it did in our 2-sum problem. So it's going to be the exact same thing as our 2-sum problem, except we are going to add one for loop outside, which is going to dictate the value of k. Now k will take values from 0 all the way to the length of the array -2. Because the maximum of this is going to be, k is going to be over here, where left is pointing right now. Left is going to point at 1 and right is going to point at 2. We obviously cannot make k point to left or k point to right, because then we'll have no space to point left and right. Now looking over here, we can see that if we want to achieve the target of 2, we have to add -1, 1 and 2. So now let us code the solution. Now the first step, I'm going to copy what code I had for 2-sum, copy it over here. We'll have to make some changes to this. I'll get back to it. The first step is, since the given array might not be sorted, I'm going to first have to sort the array. So arrays.sort numbers. Next, I'm going to initialize a for loop for the variable k. So we're going to start it for int k equals 0. K goes all the way to numbers.length -2, k plus plus. And I'm going to close the for loop over here. Now left will not be pointing to 0 anymore. Instead, it will be pointing to k plus 1. Right will still remain numbers.length -1. While left less than right, in sum is numbers of left plus numbers of right. We'll also have to add numbers of k as well, because we are doing the 3-sum problem. If sum equals target, we can directly return sum. Else if sum is less than target, left plus equal to 1. Else if sum greater than target, right minus equal to 1. So all this is fine. So if it were a regular 3-sum problem, this would be it. But since we at BreVITy like to keep things interesting, we are doing a variation of the 3-sum problem called the 3-sum closes. Now over here, the twist is that the exact target might not be available in the given array. Over here we can see that they are given -1, 2, 1 and -4, and the target is 1. And we can see that we cannot make 1 with this array. The best we can do is 2. So we are going to have to return 2. So what this means is that we have to keep track of each sum that we are getting every time we get this in sum, and we are going to have to store each time it gets closer to the target. So in the end, we'll have a variable which is going to store the value of the closest value we have gotten. So for that, we'll be using flag variables. So I'm going to say int diff equal to integer dot max value and also int closest is equal to integer dot max value. Now every time we get sum, I'm going to check if the absolute value of the sum minus target is lesser than diff. If so, then we're going to update the value of diff to math.abs of sum minus target, and I'm going to say closest. The value of closest will now be updated to the current sum. So every time when we find absolute value is lower than the earlier absolute value of difference we had between sum and target, we are going to replace the difference with the current difference which we just found, and we're also going to replace the closest value, which is the current sum. So in the end of the day, once the all iterations of the loop happens, we are going to have to return the closest value, and this should be our answer. Let me run it, check for compilation errors. That all looks good. Submitting the code. We can see that we got the solution over here. And talking about the time and space complexities, the time complexity for this code will be O of n square. And the reason it is O of n square is because we have a while loop inside a for loop. So majority of the times whenever you have a loop inside a loop, it's going to be O of n square, where n is the length of the array. And the space complexity is going to be O of 1 because we are not allocating space separately. That's it for today. We have a lot of exciting content planned for week 3, which will be a continuation of two-pointer algorithms, which will be slightly harder than the ones we tackled this week. If you haven't subscribed yet, hit the subscribe button to make sure you don't miss it. On that note, this was Rob. You're watching BreVITy. Thank you and goodbye.